Welcome, class 221B. This is group 6. We are about to go over our prep stuff. Any questions on part 1 before we get started on part 2?
I don't think so.
Everything was pretty straightforward.
All right. Someone want me? I'll read the first part. Suppose pair computing saw average of mu equals 45, so p phones per minute in 2011. And so apparently that's correct. It means that it sold 23,652,000 p phones in 2011. Standard deviation of what's that? 10, and they looked at a p phone sale and determined they are normally distributed. Mm-hmm. So question 4, looking at the sample size n equals 4 are taken from normally distributed 2011 sales data. What is the shape of the distribution?
Normal, right?
Yeah. So there's actually this one's easy because it's normal parent population, normal distribution, simple stuff. 5 is sample size n equals 40, taken from the same data. What is distribution? This is, again, like it's double whammy. It's both parent and normal, and the population size is large. So it has to be normal.
Yeah.
This is where we start in the math. 6. A sample size of n equals 4 is taken from normally distributed data with a probability the observed sample means is greater than 40. So everyone get how you find this?
Yep. Let's go over it.
Okay, sure.
Entirely sure.
This so get your calculators out. I'll go over the question with you. What we're gonna do first is use our formula. So to find the z-score, which we need to do first, you take take the means that they give you. And so for this one, a sample means is always the same as the parent mean. So the mean is going to be 45.
Okay.
But we're looking for the sample mean, which is 40. So sorry, I got that wrong. It's 40 45.
40 minus 45, right?
Yeah. So, and then here's where it gets a little tricky. You divide all that by, and I use parentheses in my calculator, because it's a sample population, it's not simply just the standard deviation, which is 10. It's 10 divided by the number of sample sizes, so 4. Because basically what we're doing is finding the sample z-scores we did in 6, where it was the mu value we're looking for minus means over standard deviation. So if you remember in sample distribution stuff, the standard means is always the population standard over the sample size.
Okay.
That makes sense.
So it's 40 minus 45 divided by 4, right?
No, divided by 10 over the square root of 4.
It's almost like the formula we did. The only extra thing is that little check mark.
Square root. Yeah. So it's exact same as what you did. So basically, if it wasn't a sample of parent population, it would be the mean, the value you're looking for minus the means over standard deviation. You get that?
Yeah.
So the only difference is we're not looking for the standard deviation of the population, but the standard deviation of the sample size. So to find that, we do value you're looking for. So z-score equals value you're looking for minus the population means with the same as sample means over the sample standard deviation, which is the standard deviation of population over the square root of the number size, which is why it's important if the sample is large or not.
Okay.
So
what'd you guys get for the z-score then?
So doing that, I get a z-score of -1. That right?
Okay, so it's 40. It's holy crap. So 40 minus 45. I'm not getting that.
All right. See, I do it 2 steps. So I do 40 minus 45 first on calculator.
Okay.
And that
gives you 5. So suppose that paragraph gives you the information for the equation. So right before question 4, part 2, it gives you the mean, which is 45, and then it gives you the sample, which is in question number 6, which is the observed x was 40, well, less than 40. So the x will be 40 minus 45, which is your average, and then you divide it by your standard deviation, which in part 2, that paragraph, it says with a standard deviation of 10. And then you would divide by the square root of 4, which it says a sample size n equals 4.
Okay.
And go ahead.
It's just doing the formula.
Okay.
Yeah. So it's important also when so if you're doing it on a calculator, what I do is the top first, so 40 minus 45, get -5. Then I take the whole answer, divide it by, in parentheses, 10 divided by square root of 4 in parentheses. The parentheses is important because you might get a wrong answer if you don't do that at the right time.
So divide for
-1.
40 minus 45 equals, and then divided by 10 parentheses.
Parentheses 10 divided by square root of 4, double parentheses at the end.
Square root of 4. -1. Perfect.
That makes sense how you get that? You got it?
Yeah.
And so once we get to -1, I think we're all familiar with the applet. You just plug in the applet and you get the value.
Yep.
Perfect.
All right, let's move on to 7. Someone want to read that?
I can do it. A sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed sample mean is greater than 35 and less than 55?
All right, so I marked it down here. The z-score for 35 is -2. The z-score for 55 is 2. So because they're equivalent, we can put it in at the area in between. If it was something like -1, the z-score for like 35 is -1, z-score for 55 is -2, we'd have to take that separately and do what you mentioned last time and pull the area. But when they're the same, we can just pull the middle section, which is 0.9545.
I got the same thing, so.
All right. That all makes sense. We're good on that question?
Yep.
Okay. Camden, you want to read the next one?
Are we on 9?
8, I believe.
Sorry. Yep. The sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that X bar is greater than 41 and less than 49? I did not do this one, so.
All right. So are we good on z-scores? Can I just tell you that we need to go over it?
I'm good on them, yeah.
Okay. So the z-score I got for 41 is -2. The z-score of 49 is 2. So again, we can take the area in between because they're matching. I got 95.45.
Okay.
Okay. I mean, that makes sense.
We ready to move on, or you need a second on that?
I'm just doing this here. Hold on.
Okay. Yeah. We'll wait. So Spencer, you said you work at hospital?
Yep, I do.
All
Yeah,
right.
unfortunately, I have to go to it's pretty.
Hey, all right, so let's move on to 9 then. A sample size of n equals 25 is taken from the normally distributed 2011 sales data. What is the probability the observed X bar is greater than 50? So it's sort of like we did last time. Basically, you take the z-score of 50 and then make sure to change your sample size at the bottom. So 50 minus 45 over 10 divided by the square root of 25. And then you take the area greater than that.
Makes sense.
So I got 0.0062. Anyone else get that? Is that what we're looking at?
Sounds good. Sounds all right.
You good, Camden?
Yep, that's what I just got.
All right, you got that?
Yep.
All right.
All good.
Someone want to read the next information box?
I can do that.
Okay.
Pair computing, so an average of, whatever that sign is, equals 40 phones per minute in 2010 with a standard deviation of 12. They looked at the P phone sales data and determined that the distribution is right skewed. Sample size n equals 4 are taken from the right skewed 2010 P phone sales data. What is the shape of the distribution of
sample? It's a sample means. So I put right skewed because we all understand why it's right skewed. That it's right skewed in the parent function, so it has to be a small. So if it's a small enough sample size, it can still be right skewed. Which is why when you go to 11, sample size of n equals 40, we can consider that large because over 30 in this class, and so it has to be normal.
When would it be less skewed?
What? Can you say it again?
I was just thinking, when would it be less skewed? You guys know? I don't know.
I'm having trouble hearing you. Can you repeat that one more time?
Yeah, when would it be left skewed?
Left skewed?
Yeah, I was just wondering out loud because I don't understand why it would be right skewed because it's also less skewed, right?
Well, it tells us it's right skewed.
Yeah. Okay.
Yeah, normally right skewed means that your outliers are all on the right side, and the main data is on the left. So you have like it's sort of like this shape. Never mind. Can't show it. But if you're having troubles with that, I would go back to chapter 3, I believe, 3 or 4, where you talk about the shapes.
So basically, like it's if it's saying it's right skewed, then the data is going to be the same. It's not going to be like skewed the opposite way,
Yeah. Yeah. The idea with the central limit theorem, which is what 12 is that if it's a large enough sample size, it wants to go to normal. So even if your data is right skewed on the parent, it will want to go to a normal idea if you get a large enough sample size, because that's what it tells us. And so 12 is central limit theorem. We get that theory. I know that was trouble last time.
Yeah, we got it.
All right. 13. Someone want to read this box?
I can do that.
Cool.
A sample of size n equals 4 is taken from the right skewed 2010 P phone sales data. And you want to know the probability that the observed X bar is less than 35. Can you compute this probability using the normal probability applet with the information you have? Why?
Go ahead.
No, go for it.
All right. So I watched the video because it's a little confusing, but it is no, because the Normal Distribution Act, as it says, is only for normal distributions. So if they gave us a sample size of 40, you could do it because it's a large enough sample size. Their sample size is 4, so it has to. So it's already a skewed population. So we cannot take it from that app.
Okay.
That makes sense.
And the only reason we can't is because it's not normally distributed.
Yeah, and that again is reflective on the sample size. So if they had said sample size of 40, we can do it.
Okay, makes sense.
All right, so where we get into 14, we talk about that. A sample size n equals 36 is taken from the right skewed data with the probability that observed X bar is greater than 36.5. So because it's a higher sample size, we can do this. If you want to take a second, compute that z-score on your own, and then we can talk about the answer.
And it's just going to be, same way as earlier.
Yeah.
Minus 40 equals divided by
All right, I got a z-score of negative 1.75. That what you guys get?
I got -2. Oh, I did 36 instead of 36.5. So yeah, I would have gotten the same thing.
Yeah.
Okay, we're good.
All right, so the z-score is negative 1.75. You plugged it in. I got 0.9599. I just left it like that because, you know, the decimal thing is kind of weird.
Yeah.
So 15, sample size of the same n equals 36 is taken from the right skewed data with a probability the observed x bar is between 35.7 and 42.7. So I calculated both of this. I seem to remember that this was one where that I did this yesterday. So it may have been when we had to do the area thing. I think it was.
Yeah, where we had to like find what's less than both of them and then subtract the.
Yeah, I believe this was one worth that.
Okay.
Let's just do it on our own to make sure we're getting the right answer.
Sounds good.
Where can I find the applet? I just lost mine.
I just googled probability applet and it was the first one.
There's several links on announcement pages. If you go to individual prep, it gives you a link. It's kind of everywhere. You just gotta look for it.
Okay, I'm gonna. Oh, here it is. Hey, sweet. Yeah, you can Google it. That's nice.
So for the first z-score, did we all get negative 1.25?
Yeah.
All right. And I got the second z-score of 1.25. That what you guys get?
Yep.
So important thing with this is because they're counter, or I don't know how to say it, but they're right. You can take the middle area.
Yeah.
So they tend to like to give us that.
Yeah, but I mean, I would assume for a test, you'd have at least one that.
Yeah, no. It's important to know that trick because our test is coming up next week.
Oh, is it next week?
Yeah, so this is the last week of material. Next week is a review lesson. So I'm not 100% sure if we're having a group meeting or not because it's all review and then we take the test. I'm sure he'll post.
I'm sure we'll still have a group meeting, but well, I mean, we'll see.
Well, and he may only have one group meeting because it's lesson 8 is a review. So we'll probably do a group meeting for lesson 8 and then have time to take the test.
Yeah, that'd be nice. Okay, sweet. Should we start this quiz then?
Yeah, let's do it.
My computer's always so slow when I'm using Google Hangouts.
What kind of computer do you have?
I have a Mac.
Yeah, I have one too. What version?
It's the MacBook Air. It's the new. No, it's not the newest one. It's the second newest Air.
See, I've heard the Airs are good for like laptops, but they have like they don't have a lot of space on them.
Yeah, that is true. It's lesson 7 this week, right? Yeah.
Yeah, lesson 7 group meeting quiz.
That first one.
I'm about to share screen. Give me 1 sec. We all good on the? Let me know when you guys are ready to start question 3.
I'm ready.
Just 1 second.
I'm ready.
All right, I'll start reading the question then. So use a normal probability applet to find a combined area under standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. So let's pull this up.
It's the combined area.
What was the number again? I have it on a separate page.
Hold on, let me pull that up here. 1.358 and negative 1.358.
All right. So you all see it on my page?
Yep.
So I'm thinking this is right. It's the greater and less than. Does that look right, guys?
Yep.
All right. So I'm getting 0.1745, probably 175. is asked around to 3 places.
0.175. Yes, sir.
Ready for 4 then? All right. Which of the following have a smaller standard deviation if 9 observations are randomly drawn for a population?
9 observations are random.
So this one, I took some looking. Basically, what I found out about the distribution of so the sample standard deviation is always going to be smaller because it's when your standard deviation of the sample matches the population, that standard deviation is 0. Because this sample standard deviation is talking about the standard deviation from the population deviation. That makes sense?
The first one, yeah.
So I believe it's the second one.
You said it's, hang on, let me think about that.
So what is the distribution of individual observations? Oh, okay. So that's just like the distribution of all 9 of the observations.
Okay, yeah.
Distribution of sample means.
So do we get what the sample mean and sample standard deviation are telling us?
Yeah, I think so.
So the sample means is always going to be the same as the population means. That's one of the rules. The sample deviation, though, is the standard deviation of population divided by the square root of the number of samples, so n. And what that does to it is it means it's always going to be smaller than the population. More importantly, if the sample standard deviation is 0, that actually means it's exact same as the standard deviation of, or not exact same, it means you have no deviation from your population.
Yeah, okay.
It's a little confusing. I had to dig deeply to get that, so I hope it's right. We're ready for 5 then?
Yeah.
Which of the following results implies that the spread in sample means decreases as the sample size increases?
This is actually the 68, 95, 95.5 rule.
Mm-hmm.
That makes sense why?
Wait, so which of the following results implies that the spread in sample means decreases as the sample size increases? No, I don't. Is that right? Is that right?
Isn't that like the central limit theorem or the law of large numbers?
Let's talk about this for a sec. That's fine.
All right, yeah.
So I'm what I'm getting, and this, to be honest, I'm not 100% sure whether it's 68, 95, 9.7 rule or the central limit theorem. The central limit theorem is talking about the shape of the distribution. Law of large numbers talking about accuracy. I believe the 69 talks about how the spread of standard deviation. So in a normal population, if the 69% of the population is going to fall under standard deviation of -1 and 1. Within one standard deviation, 68% of the population is going to be there. What it's talking about in a sample size is that you're basically taking the standard deviation and dividing it by the number of people and or the square root of the number of samples. And so I believe it's that rule. I'm going to try it and try it first and see if it's right.
Okay.
Well, we'll just see what we get at the end. Let's keep moving on then. Someone want to read the next section?
Let's see. Says, use the information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and standard deviation of 8.8. So Diane earned a score of 160 on the quantitative portion. What is the z-score corresponding to her score?
So let's just all do that on our own and we'll talk about it.
Okay.
All right, so FYI, this is just a regular z-score formula, the standard deviation, no square root, because it's not a sample. We ready to talk about the answer?
Not yet. All right.
You're good.
I got 1.045.
Yeah, that's what I got.
Yep.
So I got 2.
All right.
Perfect.
All right, then question 7. What is the probability that a randomly selected student will score above 160 on a quantitative portion? We found 160 on question 6, so we're just going to plug it into the applet and put everything higher than. That makes sense?
Yep.
Mm-hmm.
0.45. 0.148.
148.
Yep, got that too. Ready for 8 then?
Yep. I can read that.
Okay.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores?
So what it looks like is first we got to find the mean.
Yeah.
This is kind of a throwback question. Let's do that real quick.
160.
Divided by 5.
I got 160. That makes sense?
Yep.
Yeah.
So that's actually kind of funny. So what we're going to do is so do the same formula, except this time we'll do the same thing as we did for question 6. Just make sure you add in the square root of 5.
5, because it's the
Sample. Yeah.
What's the...
I got it up on my screen.
Okay.
All right, I got the answer.
Go ahead.
I got 2.238.
Same here. That seems statistically right.
That is funny that the mean of that is 160.
Yeah.
Even 60.
I doubt it's coincidence.
Yeah.
All right. Are we good with 8 then?
I think so.
All right, I'm almost there. Almost there.
Oh, you're good.
Yeah, just take your time. We're cool. It seems like statistics math is more of a logical thinking process than it is the actual math process like calculus.
I agree.
Is this
2.337?
yeah, we rounded up that 7 because there's a 7 after it. That makes sense?
So
It does.
338.
Great. Oh, all right. I remember how to do algebra. Yeah.
All right. I'm going to read 9. That good?
Go for it.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So all we're going to do is take our z-score from last 2.338, plug it in, and look at everything greater than. So I have it up here if you want to look at my page.
So it's 0.97% or point. I guess it just you just.
It'll be, well, if you round to 3, it'll be 0.01.
0 point. Well, you're gonna want to round it to 3, so it'd be 0.00. Wait, what? I can't read that.
All right, so it's 0.0097. So
I think it'd be 0. Yeah, 10 maybe.
So it should be.
Zero.
The 7 rounds at 9 up to a 1 and places a 0 there. So it should be 0.01. That makes sense?
Oh, it wants it to 4 decimal places.
Oh, okay. I didn't know it's a 4. Then we can just keep that as is, 0097.
Does that change the answers, though? Or the other answers?
Those other answers are 3 decimal places.
I think they did on purpose.
Yeah, this one's kind of awkward because if you round, then it becomes a completely different number.
I would say make sure, like, when you're taking your test, you make sure you, like, read. Because I'm sure it's going to be just like the quizzes, and he's going to tell you what to round it to. Just make sure you pay attention to that.
Yeah, so I did the homework, and the one thing I want to point out is this normal probability outlet has a tendency to, when you're doing the z-score, to input something different. So make sure you double check that z-score probability on the applet is what you're telling it is. Because I tried to put in something, and what I put in was not what it got out, so I got the answer wrong. But I did it right, and so when I put it in the second time, it was right.
Okay.
So just that applet seemed to be a little finicky. So we're good with question 9.0097?
Yep.
All right. I'll read this one. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It's well known this distribution is less skewed. A random sample of n equals 81 students will be drawn. So question 10, what is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected?
So it's normal because it's over 30.
Yeah.
You have a pretty good sample there.
Yeah. Who wants to read 11?
I can do that. What is the mean of the distribution of the sample? What is the mean of the distribution of the sample mean sampling distribution for all possible samples of size 81 that could be drawn from the parent population?
So this is kind of a trick question. We get that the mean of the sample equals the mean of the population, right? So it's 3.5. Do you get why?
Yep.
Oh, because it's the same.
Yeah. So the mean of the sample always be the same as the mean of the parent population. That never changes. That's part of the law.
Yeah, makes sense. Okay.
Yeah.
The standard distribution will change, but the mean won't.
Yeah. Standard deviation is based off the number of people. It changes based off that because it's different, but its mean is always the same.
Makes sense. Okay.
Someone want to read 12?
So it says, what is the standard deviation of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
This is just what we're doing on the preparation. We do it individually, and we'll talk about in a sec. So your equation should be 0.7, which is the standard deviation of population, divided by the square root of 81. And I got...
Yes. That goes like back to when we were doing, like originally doing standard distribution, or finding the standard distribution.
Yeah, so there's no x on top this time because that's when you're looking for a specific number. This is talking about standard deviation, which is, again, the standard deviation of the population divided by the square root of sample size.
Got it. Okay.
So I got 0.077.
0.078.
Yeah, because it's...
Yes.
I have a feeling that a lot of people will get rounding wrong on the test. Hope not, but I have a feeling that will be tricky. Yeah. Someone want to read 13? Or do we need to wait a sec?
I'm good. I can read it. So
hang on a second. So I got 0.078 on that last one.
That's what I got.
Yeah, 0.078.
Oh, okay. I just looked over and I saw that.
Yeah, no, I put it in wrong. Sorry.
that you had. I was like, okay, just want to make sure everyone's.
Yeah, no, thanks for correcting that. It is a 0.078. It's you ready for 13 then?
Yep.
You want to read it, Camden?
It says, what is the probability that the mean GPA for 81 randomly selected BYUI students will be less than 3.3?
This is just what we've been doing. We'll talk about in a sec.
Quick question. What was the standard deviation again for 13?
It was 0.078. I would type it in as the formula because otherwise you'll have rounding errors. So I got a Z-score of negative 2.571. Does that sound correct? Or did you get error stuff?
Yeah, no, that's what I got.
All right. You good, Spencer?
Sure. What was 13 again? Sorry. What'd you give it 13?
So the Z-score?
Yeah.
Negative 2.571.
Okay. Thank you.
So what we're looking for is less than. So it's actually a really small number. Let's see how many decimal it wants. 3. Okay. It should be 0.005. Are you getting that?
Yes.
I have it up here in the applet. Feel free to look off that.
Wait, why? Hold on. That's not what I'm getting.
Are you're taking the Z-score of negative 2.571, right?
2.571. Yeah, it's you
have to highlight the right side.
And then highlighting too. Okay.
Uh-huh.
All good.
Yeah, make sure you're highlighting that left area.
0.005. Got it.
Ready to move on to 14. So I want to read that.
I love it. Jeez. Sorry. I don't know her.
I got it. So what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3?
So you take the same Z-score. Actually, if you had it up on your applet, so you just do it and flip the distribution on the area.
Yeah.
So instead of highlighting the very left, you highlight the middle and the right.
Yeah, so it's 0.995.
Yeah. All right. When you're ready, I'll read 15. Are we good?
Sorry,
Yeah.
I just messed up when I did that on the calculator, so it took me a second.
All right.
Okay.
All right. 15. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value is lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weight of sample random of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that the random sample passenger have a weight that is extreme or more extreme, either above or below the mean, and was observed in the sample.
Okay, so
let's break this down. We're talking the mean that we're going to use is 185 because the sample is always the same as the mean. The standard deviation we're going to use is 26.7 plus, so we're talking about a sample size, we're going to divide that by the square root of 48.
Oh, so we're going to do 177.6 minus 185.
Yep.
Over 26.7 over square root of 48, and then everything above that.
And below. So we're not taking the middle, we're taking the minus and below.
Extreme or more, either above or below the mean. Okay, yeah. Okay, makes sense.
Let's calculate this for a second. We'll figure it out. Let me know when you guys get your z-score. I have mine.
I got it.
All right.
I'm not there yet. Sorry.
All right, yeah, we'll keep waiting.
I just got one more. I'm slow here.
I got 1.92.
Yeah, same here.
Yep.
So I have it up on my share screen. What we're looking for is the right side, left side. I got area of 0.055. Let's look how many decimals it's looking for. 3, okay, 0.055.
0.055.
We all good? I'm gonna try it once. Let me try and see if there's anything we need to correct. All right, so I got 5 wrong. That's my bad. Why don't you guys all, before we turn and change this into a limit theorem?
Can you see what else there is?
That's the only one I see wrong. So it's likely it was central limit. I wasn't sure.
The central limit theorem for the.
So question 5, which is asking, the result implies that the spread in X bar decreases, the sample size increases.
Okay.
The one we were debating about. I tried a 68-95 rule. It wasn't that. I bet it's central limit. Why don't you try it for your first attempt, and I'll change it on my second.
It's not the central limit.
Okay.
Okay, is it the law of large numbers then?
Must be.
Because it's not the normal distribution, obviously.
Who hasn't turned it in yet? The first one.
I haven't.
I tried law of large numbers. They were all wrong. Then.
Okay, I got you.
I'm writing down all the answers so I can redo it.
Yeah.
Yeah, that's. I had to do that one thing with my homework.
Taking too many online classes to not do that. So.
I got 100%. So it was the law of large numbers, which makes sense because, like it says, the large sample size means the mean that will be close to the population mean, because the standard deviation will get smaller, and so makes sense.
That makes sense. It's just kind of confusing.
Yeah.
Oh, I'm sorry. I just gotta put all these in real quick.
So make sure, Spencer, you change the 5 to the D.
Okay. What was 12 again? It was 0.078.
Give me 1 second. I'm writing down my answers.
Whew. I gotta study for this test. I gotta study for a lot of things.
I got this test coming up next week. I have I'm taking World Civ, so I got to read all of Oedipus. So all the, not just Oedipus, but the 3 Scythian plays next week.
Yeah.
And then go ahead.
7 different classes that I have to study.
Oh.
And I'm working, so like it's
7 different classes.
What?
I'm taking 7 different classes.
Yeah.
How many credits are you guys taking?
It's only 14, but
See, I'm taking 4, but they're 10, but 3, but it's 2, 3, and 2, 2. So I've got 10 credits. Since I'm a full-time online student, I don't, and I have other job responsibilities and classes and stuff here at Texas. I don't overdo it, but
yeah, dude, being in schools, it sucks. It's all right though.
I got 100. I'm good.
Sweet. Well, we'll probably see each other Monday then, or Tuesday?
Yeah, so when he posts the announcement, I mean, we'll plan on Monday at 2, unless he says not to or anything like that, and we'll see about the second one. It sounds like we probably will not have it because we'll be doing for the test, but if you want to meet and talk about stuff and prepare, that's fine too. We'll work it out in text.
Sounds good.
All right, I'm gonna stop the feed and then see you guys later.